Hi, my name is Cindy Wong, my group, and I come from group 1415. The topic that my group chose is Deadlock Safe State. So here is my group members, Cindy Wong, To Chen Ning, Wang Zhenyang, and Teo Chuan Xiang. So, what is deadlock? Deadlock is a situation in which two computer programs sharing the same resource are effectively preventing each other from accessing the resource, resulting in both programs ceasing to function. An example from US Canada's law: when two trains approach each other at a closing, both shall come to a full stop and neither shall start up again until the other has gone. So, here is the example of graph with deadlock, and this is the graph without a deadlock. So, how the deadlock prevention? The first is eliminate one or more of mutual exclusion, hold and wait, no preemption, and circular wait. Next, how the deadlock eliminate mutual exclusion? First, if your shared resource does not require mutual exclusion, for example, read-only files. Next, but some resource cannot be shared at the same time, for example, printers. The next, how the deadlock avoidance. In the deadlock avoidance, the necessary conditions are untouched. Instead, extra information about resource is used by the OS to do better forward planning or process allocation. For the example, indirectly avoid circular wait. The next, Banker's algorithm. The Banker algorithm is a resource allocation and deadlock avoidance algorithm that tests for the safety by simulating the allocation for predetermined maximum possible amounts of all resources. Then make and states check out to test for possible activities before deciding whether allocation should be allowed to continue. The last one, safe state. An OS is a safe state if there is a safe sequence of process executions. For example, P1, P2, and so on Pn. A safe state cannot lead to deadlock, and an unsafe state may lead to deadlock. You can see to this example of the picture. The deadlock is avoided by always keeping the system in a file. The deadlock is avoided by keeping the system in a safe state, and this may reduce resources utilization. That's all for me. Thank you. Hi, my name is Cindy Wong. My group and I come from group 1415, and now I'll provide two questions about deadlock safe state and I'll explain to you how to solve it. So let us proceed to the first question. Question above shows two tables. Need table is given to you and you need to find the available table. Step 1. We need to compare the number of need table with the number of available table, which is 132, to see whether the number of need table is smaller and equal to available table. So now, after we compare it, we know that P4 is true, right? After the condition is true, when the condition is true, then we can proceed to the step 2, which is we use the instance equals to available plus allocation. So now, the allocation number of P4 is 511. We just use 511 to plus the available number, which is 132, and we get 643. After we added, then we proceed to P1, which is false just now. We use the latest instance number to plus the number of P1, the allocation number of P1, which is 321 plus 643. Before we added this equation, we need to make sure that P1 is in the true condition. If when P1 is false condition, then we just continue proceed P2. So now P1 is true, right? Then we can just add it, and we get 964. After finish compare and calculate, using the same method to do the other step, which is P2 and P3. And we get the final answer of available table. And the conclusion is safe state with linear execution. And the safe sequence is P4, which is come in the first just now. Then P1, P2 and P3. That's all for question 1. Now, let us proceed to question 2. Question above provide allocation and max table. We need to find the need table and the available table. First, before we find the available table, we need to find the need table first. So, how to find the need table? We need to use the max minus allocation, which is 3 minus 1 equals to 2, 0 minus 0 equals to 0, and 3 minus 1 equals to 2. And P1, P2, P3, P4 using the same method to calculate it. After we calculate the need table, we need to compare the need table, the number of need table with the number of available table, which is 232, to see whether the number of need table is smaller and equal to available table. When the condition is true, just proceed to the next step to calculate the work number and update to the available number. So now, we compare the number of P0 first. So the number of P0 is 202. So is 202 smaller and equal to 232? Yes, right, the condition is true. So when the condition is true, just proceed to the next step to calculate the work number and update to the available number. When this is true, then we just
add the
available number and allocation number, and we get 333. Then after added, we need to use the latest instance number to plus the available number of P1. Before we added number of P1, we need to make sure that P1 is in the true condition. When P1 is in the true condition, then we can just proceed to continue the steps, and we get 645. And the rest P2, P3 and P4 is using the same method to calculate it. Then we will get the final answer, which is 12815. This is the final answer of the instance number. Then we update to this table. And the conclusion is safe state with linear execution come by first 0, which is come in the first, then P1, P2, P3 and P4. So that's all for question 2. Hope you all can understand my explaining, and thank you. That's all for me.